亲爱的朋友们，接下来让我们有请 AI 智能体的崛起作者、牛津大学计算机科学系专业硕士课程导师、艾伦图灵研究所研究员佩塔尔拉丹利耶夫先生，从学术与研究的角度，继续为我们深化对 AI 未来的认知。Let's warmly welcome Dr. Petar Rendalev, author of The Rise of AI Agents, to deliver a speech. Welcome.
Well, we heard some very interesting speeches from very important people today. The presentation that I have prepared, it's more of a technical nature. So I'm going to explain what is the biggest problem in terms of artificial intelligence today, and I'm going to propose some of the solutions. As I said, it's going to be a technical presentation, but I'm going to explain it in the least technical words that are possible. So starting from where is the problem? In 2017, we had the transformer architecture, and that started the beginning of the problem. In 2018, we had the first GPT model, generative pre-trained model. Since then, we have around 600,000 AI models in just one online repository. And that creates a problem, because everybody could take those models, adapt them, and use them for whatever purpose they want. Which means we cannot allow these models to fly around uncontrolled. So the problem is AI security and AI governance. But this debate has been ongoing for a long time. We always had the people who supported AI and the skeptics who said AI is going to kill us all. That argument no longer exists. We have to adapt and start from that perspective. If you don't use artificial intelligence, your organization will suffer, your country will have negative economic growth. So you have to use it. If that is not convincing enough, let me give you one or two examples that will convince you. In terms of science, we already have new drug discoveries based on artificial intelligence methods. And we think that we could fix the problem with cancer. And if we could cure just one disease with this artificial intelligence, most of the humans would agree that we have to continue using artificial intelligence. We also have economic improvement, societal advancement. I'll give you a different example in terms of societal advancement. Most of the taxi drivers in London would say, it took me 3 years to drive a taxi, AI cannot replace me. Now, from day one, you can have an autonomous vehicle that would drive almost the same like that taxi driver. Not good for the taxi driver, but it's good because you're going to have safer car. Look at me, for example. I'm a teacher. I teach in Oxford for the last 10, 15 years. I'm a lecturer over there. But if you take all my background from Cambridge, from Imperial, from MIT, from Oxford, those are the 4 leading institutions on the Shanghai list, cannot even be compared to what AI can do. AI could gather all the knowledge from all the institutions and build a superior teacher, virtual assistant. That's going to benefit humanity. It's not going to benefit me as a teacher, because I might be out of a job. So you need to adapt. You need to look for where do you fit, and it's the stage of adapt or die. Those are the good things. Now, in terms of the bad things, although some of them they converge, now we have teenagers with access to state-level hacking techniques. So you can have a 16-year-old teenager go to the dark web, upload a zero-day exploit, connected that to a fraud GPT, open GPT, create malicious code with around 85% success rate. So the attack surface has increased. What it used to be, let's say, 5 or 10 players, advanced persistent threats, national level security risks, now everybody has access to that. Now imagine how many attacks we can expect because of that. Too many. We cannot control them. We need to integrate AI into the defense mechanism. But how do you govern AI? Imagine that you have agentic AI system that is protecting your infrastructure. And that agentic AI system has 1,000 agents. One of those agents, agent 365, malfunctions, hallucinates, produces an error that's propagated across the whole chain of agents, and it creates a systemic collapse. That's a problem. You have to govern AI. And most organizations, companies, they don't want this, because in terms of software development, it's much easier to develop AI without implementing security measures at the beginning. It's easier to implement them later. I will convince you that that's not an option. It's not possible. You have to implement them at the beginning. And how do you convince companies to adopt security-first approach? You mentioned that there's an erosion of trust. If your clients don't trust your AI model anymore, they won't be using it, therefore you lost your business. Now, what is the next step in terms of artificial intelligence advancement? We are looking at a complete AI operating model, and there are many companies that are building this kind of models already. So on this slide, I have Ubuntu, Linux, AI, Tesla, Microsoft Azure. The chip that you can actually see on the side, that is the chip that Microsoft is developing for having a complete AI-based operating model. What's the difference between current AI and that AI? Well, the currently AI is just a feature of your operating model. It's something that it does. At that stage, it's going to be built into the actual model itself. What kind of features we can expect now and in the future? Now, if you look at just the first 3 bullet points on the slide of key features today, we're looking at improving real-time processing, improving scalability, and improving security and privacy. If anybody works in security, you know by just those 3 words that this is a cloud system. You cannot have infinite scalability, infinite real-time processing, and security in any other form of system. So we already know it's a cloud. Now, moving from that, where else would this fit? The key trends are to build neuro-symbolic AI. Neuro stands for neural nets, that's part of the machine learning. Symbolic AI is the original version of artificial intelligence that was based on mathematics and pure logic. You see that in movies like Star Trek. That AI didn't really prevail, and we're not using it today. But now we're trying to merge those two together to build a better AI. Second element that you should expect to have is quantum AI. And I know physicists would disagree. If there's anybody here that works or studies in terms of physics, would say that we would never have a quantum computer. Well, we already have quantum computers. We have them here in China. We have them across the entire world. We have one in London. Just that they're not powerful enough in terms of qubits. They don't have enough qubits, and we cannot fix the quantum correction error. Many people are working on this, and we can expect in 5, 10, 15 years' time that we're going to have a quantum computer. Where would you use this? It's not going to be your laptop. It's not going to be your mobile phone. You don't need a quantum computer for that. It's going to be based in a big data processing center. And where would that be? Again, all the data processing centers are already in the cloud. So we're shifting towards a centralized architecture that is going to become more and more centralized. In terms of security, this is a problem because you have a one point of failure. And from looking at this from a red teaming perspective and blue teaming, I belong to the red teaming, that's attack and penetration. We play with these models. We have to test them. We develop hacking techniques to see how they would behave. So what's the difference between what you have today and what we're going to have in the not very distant future? Currently, we secure the systems based on something that it's patch and pray. You find a vulnerability, you patch it, you install an update. That's how it works today. In the future, that's not going to be an option. We have to move to predict and prevent, because once you compromise the logic of the AI itself, you have to retrain the model. The common analogy that was used in the past is that blue team is the people who build the castle. But the red team, the thief, would never enter from the main door because that's where the security is. You would find the gap from behind the scene. So all that security that you're building is not really a concern for the red team. Now, how is this changing the narrative? Well, there's no longer an intruder coming through the door. The intruder is already in the castle. You have to rebuild the whole castle again. And here we have a list of the 11 most critical cybersecurity threats in terms of artificial intelligence. The top 10 is where most people pay attention to. Those are not the ones that I'm concerned about because many people are already looking into those. So data poisoning, prompt injection, they're problematic. But what is the most problematic is the last one. That's the sleeper agents. So you're building in China, you're building your model. that is going to run your energy grid, that is going to improve your infrastructure, real-time processing, yada, 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 and somebody would be able to plug in a sleeper agent. And we can do that. We have done it many times before. It's not going to be the first time. We have done it to very secure systems. So how would that sleeper agent behave? First 5 years, you're very happy with your model because it improves performance, everything is working fine. In the next 10 years, you integrate it into your energy grid, into your GPS navigation systems everywhere, hospitals. In the next 15 years, it's completely taken over. Everything is based on this AI. Your security is placed here, and then we activate the sleeper agent. And it messes up the entire system. It causes a systematic collapse. So these sleeper agents, they won't be detectable in many years because we won't activate them. Now, in terms of the red team, we have been testing this. We have been trying to create such sleeper agents and see if we can detect them. If they're malicious, we think we can. We can detect when the sleeper agent is activated if it's malicious. But remember from the beginning of the presentation, I said it's the transformer model architecture. It's generative, which means that the AI will generate these sleeper agents on its own, and it does that. Why does it do it? Error, hallucination, name it as you want, but they're born, they're not implemented by anybody. And because they're born, the AI doesn't react differently, it doesn't know that it's doing something wrong. And the activation of the neurons doesn't change. And that makes it very difficult to detect, which means that systemic risks could be caused by the AI itself, not by a malicious actor. Now, starting from the simple parts, how do you regulate this? And usually we say we put guardrails. Guardrail, as you can see on the image, is the side of the road. We never put guardrails on the middle of the road to stop the car. The intention of a guardrail is to prevent the driver from driving away from a cliff and killing himself. So in terms of AI, how do you put strong guardrails? You look at what do you have in other industries, in healthcare, in banking. So what do you have there? You have auditability, you have transparency, you have bias mitigation, you have human in the loop. Although human in the loop, many people talk about human in the loop. Humans cannot detect some of the AI vulnerabilities. They don't have that ability. Only AI can detect some of those vulnerabilities. So human in the loop is not always a solution for everything. And accountability. I have presented in the past this in the most simple way. You take 5, 10 countries, you take their national strategies, you put them into a bubble, and you create a Venn diagram. You see where do you agree, and you start from that point. You don't start from the points that you disagree, that's not going to lead to anything, but if you find solutions for problems like systemic collapse, most countries would agree that that is a problem that we could work on. Another thing that we could agree on is AI bill of material. But how would this need to be done? Remember the Shanghai Consensus, UNESCO 2012, very successful. You need something like that. An AI bill of material, it's simply a solution that when you look at the bottles that you have on the table or jam that you buy in the shops or peanut butter, when you turn it around, it has a bill of what does it contain. Peanuts, water, sugar, what does it contain? That's what a bill of material is. It just tells you what does it contain. We already have software bill of material which is very successfully being implemented. We didn't have any issues with the software bill of material. The AI bill of material is the same because AI is software, that's all there is, but it has the element of data inside. So this is a good starting point. It doesn't have to be this, but most people would agree that this is a transparent method which tells you how, not what. European Union AI Act tells you what you need to do, but it doesn't tell you how. What is the step that you need to do? Now, moving on to the questions that we have, what are the key questions that you need to ask yourself in the next 5 years? Is AI going to narrow the digital divide or increase it? If you build apps like the one that I mentioned, that you gather the knowledge from all the professors in the world and you sell that to Africa for a penny to the dollar, that could narrow the digital divide because those countries will have access to AI. But if you keep the AI to rich countries and you eliminate, because poor countries won't have access, then that's going to increase this digital divide, and that's not nice. How can we establish a global technical standards, and can we? Well, geopolitical competition is increasing already, and there is a common consensus that whoever controls AI controls the world. There are models that are diverging in 2 directions. But you need to find a focus on what key points can we agree upon. And some of those can very easily be agreed. That's governance. In terms of security, how do you secure your network? Well, think about from the beginning, not at the end. Think about what is going to be the next killer app. You already have WeChat, Alipay, very successfully implemented here. What is going to be next? Healthcare app? And then you think, what kind of risks would that app bring from, and you start thinking about that from day one, not after you build it. You cannot implement AI security after you build the app. It doesn't work like that. And now I'm ending the presentation here. My slides are coming to an end, and this one, and I have another slide. I wanted to emphasize that since ancient Greeks are one of the oldest civilizations in Europe. And one of the key technologies that they discovered was how to mint a coin. So what did they do when they minted a coin? They put artificial intelligence on that coin. And many people think that Alan Turing, the father of AI, was the inventor of AI. I work for the Turing Institute. That's not the case. Other people think that linear regression was the beginning of AI. Actually, we can find examples of AI long before that. So what did the Greeks want to do with this AI? They wanted a defender. Before we had computers, before we knew how to build any form of AI, we wanted AI that would defend us. The second image is a visualization of that. But the third image, the middle image, is the one that's important. Because as you can see, there's a charming lady unplugging a pin and killing Talos. There's blood. Talos, the robot is dying. Since ancient Greeks, they knew that we need to have a fail-safe. The pin is the fail-safe. We can agree that we need to have a fail-safe. Now, if you have a fail-safe, other people, organizations would try to abuse that and destroy your intelligence. Now, other images here is the Golem from Jewish folklore, that's AI. The papyrus paper, that's robotic hands from the Arab culture. They had their version of AI. And this is the final slide. Even Leonardo da Vinci wanted to link AI with human biological, to overcome the biological limitations. And we have in the middle 3 images of Pygmalion and Galatea, which is a sculptor, which created a sculpture that was so pretty that he fell in love with. Now, you think that's not realistic, but the last image is the image of Tilly Newworth. It's an AI-generated actress, and everybody wants to sign up to work with Tilly. Imagine that some image like Tilly is your daughter, and she makes a phone call saying that she's stuck on the train station and she needs money. Can that deceive you? It's not a sculpture, it's a real person. Now, I said at the beginning, I'm going to exclude loads of the technical details because the limitation of this presentation is only 15 minutes. I do have a book, The Rise of AI Agents, which is currently being translated into Chinese and is going to come in 2026, the first quarter, and it's published by City Press Group. Most of the technical details would be in that book. I think that's the end of my time.
Okay, thank you. That's the end, right? Okay, thanks very much for your professional sharing. Take your seat. But later you have another mission for the dialogue session. 再次感谢佩塔尔先生带给我们具有前瞻性的、非常专业的分享，掌声送给他，谢谢。